video, I am going to discuss with you about linear regression algorithm. What do you mean by linear regression? And then I am going to discuss with you about the project, how the house prices are being predicted by employing this regression, linear regression algorithm. So firstly, I am going to discuss with you about regression technique. So in case of machine learning, we have two different types of machine learning. One is called as a supervised machine learning problem, and one more is called as an unsupervised machine learning model. So in case of supervised machine learning, we have a classification and a regression problem. So what do you mean by this regression? So first I should understand the relationship between my input and output. Whether it is continuously varying or it is discretely varying. So accordingly I can say whether it is a classification problem or it is a regression problem. So what do you mean by this regression problem? So whether it is continuously varying or it is discretely varying. So it is one of the important machine learning tools. So it allows us to take decisions based on data. So it allows us to make some predictions based upon the data. So firstly I should understand the relationship between my input and output variables, how it is being related. So the output variable is dependent on the input variable. So regression. So what do you mean by a regression problem and what do you mean by a classification problem? So whenever the output variable changes with respect, what do you mean by a regression technique? Whenever my output varies in a continuous manner in accordance with the input, then it is called as a regression problem. So otherwise it is called as a classification problem. So we have two different types of regression models. One is called as a simple linear regression and one more is called as a multiple linear regression model. So firstly I am going to discuss with you about simple linear regression. What do you mean by this simple linear regression model? So it is the simplest form of linear regression model. So when compared to other type of techniques, it is the simplest form of linear regression model. So only when there is one input variable, single input variable for the output variable. So the input variable, it helps in predicting the value of the output variable. So this is what is called as a simple linear regression model. The output or the target variable, it is the variable that we want to predict. For example, y, this is the target variable, so this is what we want to predict. So this is my input variable x, so it is being multiplied by these coefficients beta 0 plus beta 1. So it is being multiplied by these coefficients and I am adding some random error term. So this is a simple linear regression equation. So whenever my output varies linearly in accordance with the input. So beta 0 is the intercept constant and beta 1 is the slope. So whenever it varies linearly with the input, then it is called as a simple linear regression model. So beta 0 plus beta 1 multiplied by x plus I am adding this random error term. So E is nothing but the random error term. It is stored in the variable y, target. Clear with this? So what do you mean by this simple linear regression model? So this is what is called as a simple linear regression model. So beta 0 is called as the intercept value. It shows the point where the estimated regression line cuts the y-axis, crosses the y-axis. It is called as the intercept constant. So it shows the point where the estimated regression line, it is going to cross the y-axis. And beta 1, it determines the slope of the estimated regression line. So the random error term, it describes the random component of the linear component between independent and dependent variables. Clear with this? So what do you mean by this simple linear regression? From the term you can just understand. So what do you mean by linear regression and what do you mean by this simple linear regression model? So beta naught, it is called the intercept value. It shows the point where the estimated regression line cuts the y-axis, crosses the y-axis. And beta 1, it determines the slope of the estimated regression line. Clear with this? So what do you mean by this simple linear regression model? So what is the aim of this simple linear regression model? So I have to estimate the parameters beta 1, beta naught and beta 1 from the sample. So what is the main aim of any type of regression model or classification model? So I have to estimate the parameters beta naught and beta 1 from the sample. So I need to find the optimum value for these parameters. A line of best fit can be used to find the values of y given the values of x. So firstly, I should understand, I should find the relationship between the input and the output. So how the inputs and outputs, how it is varying. So whether it is linearly varying or what is the relationship. So whenever my output varies in a straight line kind of a thing, linear relationship, then it is called as a simple linear regression model. So the line is used to predict the output of unseen inputs. So black dots are nothing but the observed value and red line is the predicted value. So firstly I should understand the relationship between my black dots and the red line. So how it is varying. So what is the relationship between? So black dots, they denote the observed value of y for given value of x, and red line, they denote the predicted value of y. So I should compute the slope value. So I have to choose the best fit line. So whenever I am going for any kind of supervised machine learning models or unsupervised machine learning models, so what is the aim of all these types of machine learning models? I have to minimize the error and I have to maximize the accuracy. So whatever is the type of machine learning model, so firstly I have to minimize the error and I have to maximize the accuracy. So I have to choose the best fit line. So where it cuts the y-axis, so I have to choose the best fit line such that I have to minimize the error and I have to maximize the accuracy. So the black dots, they denote the observed value of y for different values of x, and the red line, they denote the predicted value of y for x. So I have to choose the random error. So what is the error parameter? What is the error for this x value? So I have to minimize the error. I have to choose the best fit line such that I have to minimize the error and I have to maximize the accuracy. So beta naught and beta 1 values, they are estimated using the OLS method, ordinary least squares method. So how they are estimated? They are estimated using the OLS, ordinary least squares method. So what is the main goal? So I have to minimize the distance from the black dots to the red line as close to 0 as possible. So that is the main aim of any of these machine learning models. So what is the main goal of any of these machine learning models? So I have to minimize the distance from the black dots to the red line as close to 0 as possible. Clear with this? So what is the aim of any of these machine learning models? So this is the main aim of any of these machine learning models. So the difference between the actual and the predicted value is called the residual E. So it can be negative or positive depending on whether the model over predicted or under predicted the outcome. So in order to calculate the net error, so I have to add all the residuals. It can lead to the cancellation of terms and reduction of net effect. So how I'm computing this residual sum of squares? For example, I am having this. So I am subtracting this error term from my actual output. So I am just computing this residual sum of errors, I to n. So the ordinary least squares method, it reduces the residual sum of squares. So what is the main aim of any of these regression models? So I have to fit a regression line that would minimize the regression line from the observed values to the predicted values. So it is called as a simple linear regression model. So what are all the major advantages and disadvantages of going for the simple linear regression model? So it performs well for linearly separable data. So first I should understand, so whatever is the type of data, so what is the relationship between my input and output. So firstly I should understand the data, type of problem, and what is the type of input and output I am having. So it performs well for linearly separable data. So it is easier to implement. So when compared to other type of techniques, so whenever I am going for any kind of supervised machine learning models or unsupervised machine learning models, so I should consider the complexity. So it is easier to implement, interpret, and training can be done in a faster way. So all these are the advantages of my algorithm. So whatever algorithm, and disadvantage is the assumption of linearity between independent and dependent variables. So it is prone to noise and overfitting. Clear with this? So all these are the disadvantages of my linear regression model. So based on my requirement, I can go for a simple linear regression model, so or I can go for a multiple linear regression model. So what do you mean by this multiple linear regression model? So whenever my output, that is the target variable, depends on more than one input variable, so it is called as a multiple linear regression model. So basically you should understand, so what do you mean by a simple linear regression model and what do you mean by a multiple linear regression model? So I need to model the relationship. So what is the main aim of this multiple linear regression model? So I have to model the relationship between my independent variable and the response variable. So it is an extension of OLS regression. Clear with this? So it involves more than one explanatory variable. So it is an extension of OLS regression. So it uses several explanatory variables in order to predict the outcome of a response variable, multiple linear regression model. So I have different independent variables. So you can see biking to work, smoking population. So based on all these parameters, I have to predict the target. So whether a person is affected by a heart disease or he is not affected by a heart disease. So based on my problem, so I can go for a simple linear regression or I can go for a multiple linear regression model. So this type of algorithm is useful in such situations whenever the number of variables is small. So it is used in finding the relationship between my independent and dependent variables. So why I have to go for this multiple linear regression model? So you can see here, when there are two or more predictor or independent variables, so all these are the corresponding inputs, they are being multiplied by the coefficient values beta 0 plus beta 1, and it is added with the random error term. Clear with this? So I am adding these coefficients. So it is being multiplied by the coefficients and I am adding this random error term. Clear with this? So it is called as a multiple linear regression model. business model, so I should be more careful whenever I am going to work with them. So as the number of features is going to grow, the complexity of the model is going to increase. Clear with this? So what is this multiple linear regression and how I am going to be careful with this multiple linear regression model? So I just gave you a brief introduction to this multiple linear regression model. So let me just show you a simple implementation example of this multiple linear regression model. So basically I am going to discuss with you house price prediction. So firstly, as I was telling you, right, in case of supervised machine learning models or in case of unsupervised machine learning models, I have different types of supervised machine learning models and I have different types of unsupervised machine learning models. So first I should understand the relationship between my input and output, how it is varying. So whether it comes under supervised machine learning model or it comes under unsupervised machine learning models. So what do you mean by this supervised machine learning model and what do you mean by this unsupervised machine learning model? So house price prediction. So how the house prices are varying. So firstly I should understand the relationship between my input and output. So how it is varying. So based on that I can go for different types of machine learning models. Whichever model suits my problem. So accordingly I can go for different types of machine learning models. So the sale price of properties in various states. So in real estate, whenever you consider, so you have to consider how the house prices are varying. So accordingly I can go for this clustering technique. So or I can go for this linear regression model and I am going to discuss with you how the house prices are being predicted by employing this linear regression model. So as I was telling you, right, for doing any kind of machine learning development, features are very, very important. Features are nothing but important pieces of information which help us in solving the problem. So whatever is the type of problem, so how I am going to solve the problem with the help of various types of features. So there are many factors or features which affect the house price. For example, I can include the area of the property, location of the property and its amenities. So I have to construct a predictive model for evaluating the price. Based on all these factors, I should consider a predictive model. So currently in the existing system, so they have employed different types of classifiers like Bayesian classifier. It is one of the classic statistical techniques for accessing the relationship between the target variable and the independent variable. So the Bayesian classifier techniques, they are widely employed to build a model based on several factors in order to predict the price. So in this, an attempt has been made to build a house price prediction classifier model for dataset that remains accessible to the public in machine platform. But what is the disadvantage of my existing system? It is less efficient and less reliable when compared to other type of methods and not suitable for all types of data. So all these are the disadvantages of my existing system. So in order to overcome the disadvantage of my existing system, so I am coming for a proposed system. So what happens in the proposed system? So in order to overcome the disadvantage of my existing system, so I said I am coming for a proposed system. So what happens in the proposed system? So it is a generic application, it can be accessed from different locations. So whenever I want to predict the house prices or insurance prices, so I am going to employ this linear regression algorithm and it can be used to predict the house prices. So what are the major advantages of my proposed system? More efficient and robust. when compared to the previous methods, it is more efficient and robust. And it is suitable for large amounts of data. So all these are the advantages of my proposed system. So when you look at the system architecture, so all these are the different blocks that are present in the system architecture. So I have a data set block. I am going to collect the data sets from various sources. And then I have a pre-processing block. So whenever I want to do some sort of encoding or null value removal, so everything happens in the pre-processing block. And after pre-processing, it is given to the feature extraction. So I am going for different types of classifiers, regression classifier, and I am calculating the accuracy score here. And what are all the different hardware and software requirements that are essential to do this project? So I require a Windows 7, 8 or 10 64-bit operating system and 4 GB RAM memory capacity. And software requirements, I require a data set, so everything is written in Python language. I require Anaconda Navigator and Python standard library. So all these are the different hardware and software requirements that are essential to do this project. So let me just show you a simple implementation example of this. So firstly I need to import the essential libraries. So what are the required libraries that are required for my development? So firstly I need to import the corresponding libraries. So all these are the different libraries that are required for my development. So firstly I am just importing this NumPy library. NumPy stands for numerical Python. And then I am importing this Seaborn library. So what is the use of Seaborn library? It is used for performing any kind of data visualization task. So any kind of data visualization task, it can be done using this Seaborn library. And Matplotlib library, so it is used for performing any kind of data visualization task. So firstly I need to import the corresponding libraries. After importing the corresponding libraries using the alias name, so I am just reading the CSV file. So train.csv and test.csv, they are stored in the variable train and then test. So on that train.head function, it is going to print the head of my data frame, the first 5 rows of my data frame. And train.shape, so what is the shape of my training data? It returns a tuple containing the number of rows and columns. The first dimension denotes the number of rows, the second dimension denotes the number of columns. And train.info function, it just provides an information about my data frame. So totally how many entries it contains and what are all the data types of different columns. It contains some integer data types, object types, floating point types. So totally it contains some 3 floating point types, 35 integer types, object types, and memory usage 924.0 plus kilobytes of memory it consumes. And train.d type, so what are the data types of training data? So it contains some integer data type, floating point type, and plt.subplots. Whichever inbuilt functionalities of Matplotlib I want to use, using the alias name, using dot operator, I am just calling this subplot function. And figure size, so whatever is the figure size, I am giving the figure size as 12,9 figure window, and I am showing in the form of a distribution plot here. So train of sale price, so whatever is the sale price I am giving here, and I am storing this mean and standard deviation value. And plt.legend function, so whatever is the legend, I am calling the corresponding inbuilt function of this Matplotlib library. and PLT dot Y label I am giving here as frequency, and then I am creating a figure window using this matplotlib alias. So I am taking the sale price along the x-axis and the frequency, so whatever is the mean and the standard deviation value. So I am showing in the form of visual plots, EDA. So whatever is the X label, Y label. Clear with this? So what is the mean and standard deviation values? So train dot column. So train dot, there is an inbuilt function called isNull function. So isNull function, it is going to return me a boolean value of true or false. So I am going to check if there are any missing value in my training data, and I am showing I am plotting a figure window, I am creating a figure window using this matplotlib alias. Clear with this? So what are the different things I am doing here? So SNS dot heat map. So whenever I want to create heat map using this Seaborn alias, I am just creating a heat map. So how all this comes under EDA, exploratory data analysis. And using this training data dot isNull. So I am checking if there are any null values in the training data. So I am just summing up the null values and I am sorting them. And isNull dot toFrame function. So whenever I want to convert to the data frame, so I am just calling this function called toFrame function. It is stored in the variable isNull. So whatever is the count I am taking, it is stored in the variable isNull dot columns, and name, it is stored in the variable isNull dot index dot names. Plotting the missing values, PLT dot figure. So whenever I want to create any figure window, so figure size equal to 13,5. And SNS dot set function. So style I am giving here as white grid and bar plot. So I am just showing in the form of a bar plot. So you can see here pupil, QC, alley, fence. So they are indicated by different colored bars, the count. And what are all the different data types I am selecting, and train correlation dot shape. It returns a tuple containing the number of rows and columns. So using the Seaborn alias, I am just showing in the form of a heat map. So SNS dot heat map. So I am passing this correlation and anot equal to true. So whenever I want the numbers inside the cell, so I have to set this parameter anot equal to true. And from this training data, so overall quality dot unique. So I am picking up some unique values from this overall quality. And using this Seaborn alias, I am just calling a bar plot. Clear with this? So all this comes under EDA, exploratory data analysis. So for doing any kind of machine learning development or data science development, EDA, exploratory data analysis, it plays a very, very important step in improving the accuracy of my entire prediction result. So using this matplotlib alias using dot operator, so I am just creating a figure window. And I am showing, for example, figure size I am giving here as 18,8, whatever is the size of my figure. And SNS dot box plot. So train dot overall quality, train dot sale price. So it is stored in the variable X and then Y. So I am picking up the columns. So what are the different columns that are present in my data frame? So there is a variable called column variable. 1 minute, let me just continue. I am just picking the sale price. I am sorting them in the descending order. So ascending equal to false. So from this training data, so pool quality, miscellaneous feature. So I am going for different types of aggregation functions. Group by function, fill NA function. From sklearn.preprocessing, I am just importing this label encoder. So whichever modules I want to import, so I have to import the corresponding module from sklearn.preprocessing. So from sklearn.preprocessing, I am just importing this label encoder. So for C in calls, so I am picking each and every column present in this call. So I am just initializing this label encoder. It is stored in the variable label. And using this label dot fit function, so list of train of C dot values I am picking, I am transforming this. So from this training data, I am picking the sale price. And then they are stored in the variables X and then Y. From sklearn.model selection, I am importing a train test split module. So this is the next step involved in my development. So I am just initializing this train test split module and I am passing all these parameters, whatever is the X parameter, Y parameter, test size. So I am going to split them into 80% training data and 20% testing data, and random state equal to 7. And from sklearn, I am importing the linear model. So linear model dot linear regression. So I am just initializing this linear regression. It is stored in the variable model. Model dot fit function, it is used for training the machine learning model. So X train and Y train are given as inputs. And finally I am predicting something and I am showing the accuracy score here. It is 89.2% accurate. So I hope I am clear with my topics. I just gave an introduction to linear regression algorithm. And I gave you a brief introduction to how the house prices are being predicted by employing this linear regression model. If you have any queries, you can post your queries in the comment section. Remaining things, I will just continue in my next videos. Thank you all.